In this video, we're going to look at a full energy budget. We're going to look at all the exchanges of energy as well as how they work together to balance the radiative equilibrium and keep us to maintain temperatures as much as possible. A couple of things to quickly review as we get started. As far as the greenhouse effect goes, remember that the Earth is both simultaneously receiving shortwave radiation from the sun and emitting long-wave radiation from the Earth back out into space. In fact, our atmosphere is constructed in a way such that the molecules, remember that these are selective absorbers. They absorb radiation at particular wavelengths, and if they're good at absorbing at those wavelengths, they'll also re-emit at those wavelengths. There are two windows inside of our atmosphere. The visible window, where the shortwave radiation from the sun can come through down to the surface of the Earth, and the atmospheric window, a range of wavelengths where the atmosphere is strangely not very ideal at emitting radiation, absorbing radiation. And so that radiation is emitted out to space, basically prevents overheating, keeps us from absorbing and trapping in too much heat. Other than that, these molecules will absorb and re-emit energy from all of these other wavelengths and emit them and back down to the surface, keeping us from getting too cold at night and from getting too cold in the winter. Also remember our full heating picture here. We need to maintain radiative equilibrium so that our temperature doesn't change. I know temperature does change from day to day and season to season, but that'll be the next chapter. For now, we just want to see the balance. So in order to have a balance, we need to maintain radiative equilibrium. If we are absorbing more energy than what we're releasing, then we have a surplus of energy and the temperature rises. But if we have a deficit of energy, meaning we're emitting more radiation than what we're absorbing, then energy levels will drop and we will cool down. So that takes care of the radiative equilibrium. But the other part of this whole picture is the part of weather, conduction and convection within our atmosphere, creating this cycle which actually helps to transfer some energy and restore any imbalance there. Let's take a look at a full energy budget. Here's a picture that shows an energy budget, the calculation of the balance of energy between the Earth, the atmosphere, and space. Okay. Remember that of insolation, that's short for incoming solar radiation, about 30% of that is reflected back out into space. The other 70% comes down and is either absorbed by the atmosphere or reaches the surface. While this is happening, the surface of the Earth is also emitting radiation, some of which gets absorbed by the atmosphere, some of which makes it all the way out to space. The atmosphere itself is also emitting radiation, some of which goes out to space, some of which goes back to the surface of the Earth. Okay, here's the balance. Are we ready? Let's look at how much energy we at the surface would be absorbing. That'd be 51 units from solar radiation, but we're also absorbing a certain amount of energy from the atmosphere. So let's, assuming we're just talking about units here, where 70 units of insolation are coming in, the 51 from the sun and the 96 from the atmosphere total to a gain of 147 units of energy that we gain at the surface. Now, if we just gain, our temperature will increase, but we don't want it to increase. We want to have a balance, and that happens as 117 units are emitted away from the Earth. So that energy is radiated away. So we're gaining 147, we're losing 117. that means that we have a surplus of 30 units of energy. The difference between 147 and 117 is 30. And again, that's not a hard number. It changes from day to day and from season to season. But just in this example, we'll just carry on with this example here. There's a surplus of 30 units of energy. Well, where does that energy go? Talk about that in a second. Let's look at the atmosphere. In the atmosphere itself is radiating out 160 units. 64 units escape out into space, and 96 units go back to the surface of the Earth. That's a total of 160 units lost by our atmosphere. So how do we balance that? Well, over here, the atmosphere is also absorbing 111 units that's coming from the Earth's surface. And it's also absorbing 19 units from the sun. 111 plus 19, that's 130. So we're absorbing 130, but we're losing 160. That gives us a deficit of 30 units. Interesting. So down here at the surface, we have a surplus of 30 units. In the atmosphere, we have a deficit of 30 units. Then said in other words, at the surface, we're absorbing 30 units more than what we're emitting, but the atmosphere is emitting 30 units more than what they're absorbing. Okay. Final stage of this is the atmosphere itself going out to space. The surface of the Earth is losing 6 units of radiation. The atmosphere is emitting 64 units of energy. 64 and 6 together is 70, which perfectly balances the 70 that are coming in, which puts the overall atmosphere in a perfect balance. The only thing we have to deal with is the surplus of 30 at the surface and the deficit of 30 in the atmosphere. How do we fix that? Well, we get the surplus of 30 units at the surface into the atmosphere through evaporation and latent heat, and through conduction and convection. In other words, weather. This weather is really just a part of the processes in the atmosphere that help to balance the energy. And there you go. There's a whole picture of the Earth atmosphere energy balance. Now, if we can get all these numbers to balance, then we're continually in radiative equilibrium, which means our temperature is going to remain steady. And as I've mentioned a few times, if there's a surplus in one region, it's going to have a surplus of energy, temperature is going to rise. If there's a deficit, temperature is going to decrease. Now, let me give you a simple example of 2 different regions along the Earth's surface where you're going to deal with those surpluses and deficits. We've looked at an energy budget vertically, going from the surface of the Earth all the way out into space. But now let's look at it horizontally. Near the equator, you're always going to have a surplus of energy. You are always absorbing more energy than what you're losing. You're always going to have that surplus. And on the flip side of that coin, near the poles, you are always going to have a deficit. You are always going to lose more energy than what you gain. So why doesn't the equator just continually get hotter and hotter and hotter and hotter and hotter? And likewise, why don't the poles keep getting colder and colder and colder? Well, it's because with a surplus of energy near the equator and a deficit near the poles, energy is transferred from the equators towards the poles. How? What process makes that happen? There needs to be some sort of a horizontal heat transfer that balances the energy horizontally as well. Now, perhaps one of the best examples of how this happens is hurricanes. Hurricanes are going to draw a lot of energy from the equator, and then they start to move poleward, and they dissipate as they lose that energy into the environment around it. So once again, weather becomes a process to help balance the energy horizontally. And that's the energy budget. And that it's a good picture, good view of all the interplays of energy within our atmosphere, surface of the earth, and space, how all of these play together. In fact, let me go back here just to emphasize this balance here between space, atmosphere, and surface of the earth, how they interplay so much. And then if there's any sort of misbalance, temperature is going to rise or fall depending on what type of misbalance you have. And this is what we play with all the time in meteorology. Is there going to be a gain of energy, or is there going to be a loss? If there's a gain, then we're going to rise in temperature and so on. In chapter 3, we're going to look at how this happens on a daily basis. Instead of talking overall, we're going to talk about how it happens on a daily basis as well as on an annual basis, creating seasons and the daily temperature cycle. And that will be in chapter 3. But we have one more video left, chapter 2, and here we get to go into a really cool topic that I really love called space weather. We'll see you there.